Okay, welcome back. We're going to be working on Unit 4, free response question B for the next several minutes. This is a derivative question in some context, with some context applied to it. So we have the depth of the river at a certain point is being modeled by this function W, which is described as a piecewise function. W is measured in, WT is measured in feet, and time T is measured in hours. So W in feet and T time in hours. Find W prime of 8. Well, the first thing we need to find is we need to find W prime of T. And since we're going to evaluate at 8, this bottom part of the piecewise function is described for the domain 6 to 10. So W prime of T, we're going to need to take the derivative of 10, which is 0. Minus 1/5 is just a scalar multiple. I'm going to leave it there. I'm going to apply the power rule, bring the 2 down. T minus 6 to the 1, and then the chain rule times the derivative of the inside, which is just 1. W prime of T is equal to negative 2/5 T minus 6. Now we're going to evaluate at 8. W prime of 8 is equal to negative 2/5 times 8 minus 6. And the AP exam encourages you just to leave it like that. But if we did want to simplify, 2, we did negative 4/5 or negative 0.8. They'll accept it in a bunch of different ways here. So we need correct units here, and we can put our units here, and then we can put in our explanation as well. So the units, since this is in W's in feet, so this would be in feet per hour. This is a rate that the depth of the river is changing at. So that's what we're going to have to write over here. Is because they do ask us to explain. We did the units already. W prime of 8 means that the depth of the river is decreasing at a rate of 4/5 feet per hour at T equals 8. So W prime of 8 means that the depth of the river is decreasing at a rate of 4/5 feet per hour at T equals 8. We want to make sure we mention that it is a rate, and we need feet per hour, and we need negative 4/5. Part B, the graph of W is concave down from 3 to 3.5. Use a line tangent to the graph of W at T equals 3 to show that W of 3.5 is less than or equal to 9. So let's start with the tangent line first. If we want the tangent line at T equals 3, we are going to need the value of the derivative of W at T equals 3, and that provides us with the slope. So since we're using T equals 3, that would be in the first part of the piecewise function, the top half. So we're going to need W prime of T for this top part here. So we have a 17 over 2, which becomes 0. And we have a negative 3/2, which is a constant multiple or a scalar multiple there. So negative 3/2 times the derivative cosine, which is negative sine of the inside, pi T over 6. And then times the derivative of the inside, which is pi over 6. So we have something like that, and maybe we could simplify it a little bit. W prime of T is equal to, we have negative 3 pi over 2 and 6 is 12, so negative 3 pi over 12. And then we have a negative, so positive, so how about a pi over 4? Again, because of these two guys just simplified together there. And then sine of pi T over 6. How's that for the derivative function? Okay, so W prime of 3, pi over 4, sine of, plug in 3 for T, so 3 pi over 6 is pi over 2. So W prime of 3, again, this is a no calculator question here, so sine of pi over 2 is 1. So we have pi over 4 is the slope of our tangent line, and we know that the x-coordinate is 3, and now we need the y-coordinate, so w of 3. So again, we're going to use this top part, but not the derivative of it. So 17 over 2, I'm just going to evaluate at 3. Cosine, plug in pi 3 over 6 is pi over 2. Cosine of pi over 2. And let's see what we have here. Equals 17 over 2 minus cosine of pi over 2 is 0. So how about just 17 over 2 for the y-coordinate? So we have y minus the y-coordinate equals the slope, pi over 4, from right here. X minus the x-coordinate. The x-coordinate is 3. And I'm just going to rewrite this as y equals, move the 17 over 2 to the other side, pi over 4, x minus 3. Now if we're going to use the approximation at 3.5 to approximate w at 3.5, we're going to plug it in here. And we know, since it's concave down, that this approximation, the actual value of the function, has got to be less than what this guy is. So when we plug in 17 over 2 plus pi over 4, and we're going to plug in 3.5, so 3.5 minus 3, so w of 3.5 is less than 17 over 2 plus pi over 4 is 1/2. So w of 3.5 is less than 17 over 2 plus pi over 8, and this value is less than 9. This is less than 1/2, and 1/2, 18 over 2, 18, 1/2. If this was 1/2, this would be 9, and this is less than 1/2, this pi over 8, so it's got to be less than 9. And again, this all has to do with the fact that the graph is concave up. So a tangent line approximation, which is this w of 3.5, has to be less than the actual value at the function. Okay, last question for this is part C here. This is a limit. We're going to remember our first attempt at limits is to use direct substitution. Let's not just assume it's going to be a L'Hopital's rule here. Let's try direct substitution here. So the limit, as t approaches 2, we can evaluate it. So we can try w of 2 minus 2 to the third plus 1/4 over 2 minus 2. So w of 2, we're going to plug it into this, to the top half of the piecewise function to find w of 2. So 17 over 2 minus 3/2 cosine, I have pi 2, so pi over 3. And then minus 2 to the third, which is 8, plus 1/4. 2 minus 2 is 0. So let's go over here, put that equal sign there. And I believe that numerator gives us, let's see, we got 17 over 2, got the cosine of pi over 3, which is 1/2. So 3/4 minus 8 plus 1/4. So yeah, we have over 0. So we have 8.5 minus 0.75 minus 8 plus 0.25. Minus 0.5 should be 0. So we get 0 over 0. So let me just, I went off my screen there. No one there to yell at me. So as you can see, 0 over 0. So we've now shown that it's an indeterminate form limit. So we can use L'Hopital's rule and we can find the limit as t approaches 2. The derivative of the numerator is w prime of t minus 3t squared. The derivative of 1/4 is 0. Derivative of t is 1. Derivative of minus 2 is 0. There you go. So the limit as t approaches 2 of this guy I don't even need to write that again. We can just show that we're going to use direct substitution. So w prime of 2 minus 3 times 2 squared. W prime of 2 is the derivative of the top part of the piecewise function, the 17 halves minus 3 halves cosine, etc., which is going to be, I believe, right here. So pi over 4 sine of, we're going to plug in 2 for t, and that's pi over 3, minus 3 times 4 is 12. And I am just going to leave it like that, because that is what AP encourages us to do without simplifying. So a little longer than a couple of other ones, just hitting about 11 minutes. Longer problem here. I hope this helped you make it through the problem.